Hello and welcome back to an Introduction to Scratch 3.0 Part 4. My name is Laura, and today we're going to learn about moving and sensing. Moving and sensing work hand in hand to make Scratch projects more immersive. Motion blocks adjust a sprite's X and Y coordinates to influence where and how a sprite moves across the stage area. Sensing blocks give sprites the ability to detect their surroundings, such as other sprites, colors, or the edge of the screen. And by using moving and sensing blocks with if-then statements, you can create more complex interactions for your sprites. To get started today, you just need to head on over to Scratch, create a brand new project, and pick some of your favorite sprites to work with. And when you're ready, I will meet you in the Inside Project view. So to get started today, I hope that you've picked some sprites that you want to work with. I have some sprites in mind that I'd like to choose, so I'm just going to head into the sprite library here. I discovered them quite by chance by browsing through a couple of these different categories. The first one I found was in the people category. And contrary to what you may be thinking, it's not a person. The sprite that I'm going to use from the people category is Wizard Toad. But we need at least 2 sprites for this project, which is great because there's definitely one other one that I would like to use. In the food category, lots of great foods to choose from, with interesting animations, including this egg, which seems like it's cooking itself at one point, which is a little bit disturbing. But the one that I'm going to use is the taco, which is also a taco wizard. And I'm just gonna... Excellent. Okay, let's get started. So we're going to build a script that will get our sprite to interact with its surroundings. And right now there isn't a lot here, just the taco wizard and the wizard toad. But there's also your mouse pointer. And we can build a script that will have our sprite notice where our mouse pointer is, wherever it happens to be on the screen, and also react to it. So we're going to begin that script with a hat block in the events category. Let's pick the first one on the list there when green flag clicked. And to get our sprite to notice where our mouse pointer is on the screen, we're going to need some motion blocks from the motions category. Down the list here, we have the very handy point towards blocks. And the one we're going to use in our script is the point towards mouse pointer block. So let's click and drag that to our script. So now when we activate this script, our sprite is able to detect where our mouse pointer is, which at the time of running the script was on the go button. But it would be a lot more interesting if our sprite could move towards our mouse pointer, and to do that we want to add a move block to our script. So let's grab the move 10 steps block, add it to our script so far, and activate it. Now our sprite will slowly inch towards our mouse pointer. So let's take it up a level. Let's go to the control category, grab a forever loop, and wrap it around those motion blocks. So now when we activate our script, our sprite will always move 10 steps towards our mouse pointer. And let's see how it does. There we go, we are being chased by the taco wizard around the screen. Even when my mouse goes off the screen, my sprite still appears to know where it is. However, when it catches it, my sprite gets really confused because, as the script says, it should always point towards my mouse pointer. So once it actually reaches it, it's not really sure where my mouse pointer is anymore and doesn't really know which way to point. And this is where we can add some more blocks to set conditions for our sprite that will tell it to just relax once it reaches our mouse pointer. And these conditions can be added with if-then statements. You can find if-then statements in the control category just underneath the forever loop. And there are 2 that you can pick from. There's the if-then block and the if-then-else block. One of the more noticeable things about the if-then statements are these hexagonal input spaces between the if and then. This is where we're going to add the condition for our block so that our sprite will know to meet that condition and then perform certain actions. For example, if I were to go to the library, then I would sign out a book. So for our sprite, we could add any kind of condition into that input space as long as it has a hexagonal shape. And we can find hexagonal blocks in the sensing and the operators category. So let's take a look at the sensing category first. And inside the sensing category, you're going to find all of these different blocks that will help our sprite detect what's around them. And the one we're going to start out using is the touching mouse pointer right at the top of the category there. If we nest that inside the if-then block, we've now added a condition for our sprite to follow. If our sprite touches the mouse pointer, then it should do the following. So now that we have our condition, if the sprite is touching the mouse pointer, we now need to add an action that will happen when that condition is met. So you can add whatever block you want inside of the if-then statement for the action. I'm going to go over to the control category and maybe add the wait 1 second block. Using the wait 1 second block, we'll just tell my script to wait and pause before continuing to chase the mouse pointer. And now we need to add our statement to our script. So let's nest it inside the forever loop because we always want it to be active, and maybe just underneath those motion blocks so that our sprite knows to always be pointing towards the mouse pointer and moving 10 steps towards it. However, it'll still know that if it touches the mouse pointer, it has to stop doing that. So let's see if it works. So our sprite already touched the mouse pointer, now it's chasing it again, and it's touched it again and stopped. You'll notice though that if I don't move my mouse, my sprite will continue to inch towards my mouse pointer until it's not sure which way to point anymore. If we use the reporter block, distance to mouse pointer, from the sensing category, we can allow our sprite to judge the distance between it and the mouse pointer and maybe stop a little bit early before it gets too confused about which way to point again. But you're probably thinking, this reporter block is round and doesn't fit in a hexagonal shape. You're completely right, which is why we need to add an operator block. If you go over to the operators category, you will see a couple of different hexagonal blocks that we can use. And the one we are going to use is the first hexagonal block, something is greater than 50. This is going to tell our sprite that if the distance of the mouse pointer is greater than 50 steps, it will do the following. So let's nest that right away into our if-then statement, head back to the sensing category, and nest the distance to block inside the first input space of that operators block. So this new condition in our if-then statement is telling our sprite that if the distance of the mouse pointer is greater than 50, then it should do the following. So if our sprite is more than 50 steps away from our mouse pointer, we probably want it to move towards it still. So let's take out that wait block, grab those motion blocks, and nest them inside the if-then statement. Then let's wrap it all in the forever loop because we always want it to be active. So now, if our sprite is greater than 50 steps away from the mouse pointer, then it's going to point towards the mouse pointer and move 10 steps towards it. The nice thing about the script is that we don't really have to specify what our sprite should be doing if it is closer to our sprite than 50 steps. Our script just knows that it doesn't meet that condition and therefore it won't be active on the screen. And just to show you what I mean, let's give that a try. As you can see, my sprite is within 50 steps of my mouse pointer, and it knows that it doesn't have to be moving towards it anymore. However, if I increase the distance between the sprite and my mouse pointer, I'll still get that great chase across the screen. And you can adjust how fast your sprite is moving by changing the number in the move block. So right now it's at 10, but I could say 2 instead. And when I run my script, my sprite will drift very casually across the screen towards my mouse pointer. We're now going to create some scripts that will allow our sprite to sense what keys we're pressing on our keyboard and then move in certain directions depending on what keys we press. So I'm going to switch over to my other sprite here, the wizard frog, and I'm going to begin with a hat block, just like we always do. And I'm going to use the when key pressed block. So this hat block uses the space key to tell the script when to run. And now we're going to use a lot of if-then statements. So let's go to the control category, grab an if-then, and add it to our hat block. The condition we're going to add into this if-then statement is a sensing block that will allow our sprite to detect when we're pressing certain keys on our keyboard. So let's go to the sensing category, and we're going to add the key pressed block to our if-then statement. This sensing block is allowing our script to sense what key is being pressed on the keyboard, and we can choose whatever key we want from that drop-down menu for our sprite to react to. We're going to pick one that's going to tell our sprite to move to the right. So I'm going to select right arrow. And now we need to add a motion block that will tell our sprite to move to the right. In the motions category, we don't really have a move block that tells our sprite to move directly to the right. What it does have are these XY blocks down here. Now these XY blocks work with the coordinate plane, which is how Scratch determines where your sprites are on the stage area by giving them certain kinds of coordinates. And you can find those coordinates down there in the sprite pane. The X coordinates refer to how far left or right your sprite is on the screen, and the Y coordinates refer to how high or low your sprites are on the screen, and those numbers change depending where your sprite is located. Now, in order to get our sprite to move to the right, we need to modify its position on the x-axis, which controls how far left or right it is. So let's grab the change x block and add it to this script. If I set my sprite at the center of the screen, which is 0, 0, as we've learned before, and then enter 10 into the X input space, my sprite will move very gently to the right. And if I add an additional 10 to 10, which would be 20, my sprite will move again to the right. However, if we wanted our sprite to move to the left, we'd want to minus 10, correct? So from 20, we would minus 10, make it back to 10. And if we didn't want 10 anymore, we would minus 10 again to make that 0. And if we wanted our sprite to go further to the left, we'd have to use negative numbers. So minus 10 from 0 would be negative 10. And our sprite would move to the left, etc., etc., etc. So now that we have a script that tells our sprite to move to the right, we're going to create that script that tells our sprite to move to the left. And it's going to be a very slightly modified version of this script. So let's go back to the control category, grab an if-then statement, grab that sensing block from the sensing category that says key pressed, and change the key from the drop-down menu to whichever one you'd like to press to make your sprite move to the left. And because the x-axis controls how far left or right the sprite is, we're going to need another change x by block. So we'll go back to the motions category. We're going to use a change x by block in our new if-then statement. And now that we know that positive numbers will have our sprite move to the right on our x-axis, we're going to use negative numbers to have our sprite move to the left on the x-axis. So instead of using 10 here, we're going to say negative 10. And before we test this script, we need to add a forever loop to these if-then statements in order for them to always be active. So let's go to the control category, grab a forever loop, and wrap it around all of those if-then statements. So now when we activate the script by pressing the space key, we can use our arrow keys, left and right, to move our sprite around the stage area. The logical next step, of course, now is to create scripts that will allow our sprite to move up and down, and these will be controlled by the y-axis. So we're going to use the same hat block we just used so that both of them run at the same time. We're going to grab another forever loop so that they will always be active, and a couple of if-then statements to add to the inside of that forever loop. And let's add conditions to those if-then statements with the same key pressed blocks. And now we need to adjust these sensing blocks so that they have the correct keys being pressed. So for the first one, I'm going to choose the up arrow, and the second one, I'm going to choose the down arrow. We've learned that the x-axis controls how far left or right a sprite is, and now we need to play around with the y-axis to allow our sprite to move up and down on the screen. So we're going to go grab some blocks from the motions category, and the ones we're going to use are the change y by blocks. So you can grab one of those and nest them in each of the new statement blocks. So if we want our sprite to be moving up, we need to know whether the input space in here needs to be a positive number or a negative number. So let's go to the sprite pane and let's modify its current position. Right now it's at 0 on the y-axis, but if I add a positive number into that space, my sprite begins to move upwards. And I can make that more dramatic. There you go. And if I add a negative number, say minus 50, it's going to start moving down the screen. So we know that positive numbers will bring our sprite upwards and negative numbers will bring our sprite downwards. So in those motion blocks now, we need to alter them so that they meet those conditions. If the up arrow is pressed, we want our sprite to change its Y position in a positive way, so we'll leave that number at positive 10. And when we want our sprite to move downwards, we need to change its Y position by negative 10. Great, so now when these scripts are active, we can move our sprite up, down, left, and right. And by using a combination of keys, you can even make your sprite move diagonally. Let's make these scripts a little bit more fun by adding some costume changes whenever our sprite moves in a different direction. So we're going to go to the Costumes tab, and right now I only have 2 costumes for this sprite. So we're going to create some extra costumes that will make our sprite face the direction that it will be moving. An easy way to do that would just be to duplicate the ones you already have, and then to use the flip horizontal or flip vertical to change the direction that they're facing, like so. Or you can use the select tool to select your sprite and then change the direction that it is facing. The next step, of course, is to label each of these costumes. So Wizard Toad A is facing to the right, and therefore I'm going to call that costume right. And I'll call the left-facing costume left, the up-facing costume up, and the down-facing costume down. Now we need to add some blocks of code to our scripts that will tell our sprite to change costumes when it moves in a different direction. So we're going to go to the looks category, grab the switch costume to block, and nest that just below our motion blocks in each of our if-then statements. And now we need to make sure that the costume that it's changing into matches the direction it will be moving. So for the right arrow, I want to change that costume to right. For the left arrow, I want to change it to left. The down arrow, I want to change it to down. And the up arrow, I want to change it to up. And before you test out your scripts, just to make sure your sprite is ready to face the directions that it's moving, just double check that its direction in the sprite pane is set to 90 so that it's not facing in an awkward position when you actually begin moving. Okay, let's give it a try. So my sprite is now moving to the right, to the left, up, and down. The last thing we're going to do today is slightly modify the first script that we built for our first sprite. So right now the sensing block in the script is telling our sprite to pay attention to our mouse pointer, but let's have it pay attention to our other sprite and sense where it is. Let's swap out some of these blocks here and put in some new conditions to this script. The condition we're going to use is the first one in the sensing category, the touching mouse pointer block. However, from the drop-down menu in that sensing block, we're going to select not the edge of the screen, but the Wizard Toad, your other sprite. And now we need to pick some sort of action to happen once it touches the Wizard Toad. Feel free to use whatever block you would like as a result of touching the Wizard Toad. I'm going to use the looks category to change to next costume. And I'm going to maybe ask it to say something. There we go. So it'll change costume and then say something for 2 seconds. I'll just say, magic! So when this is clicked, if my other sprite moves towards it and touches it, it says magic and transforms into a taco. And if it hits it again, it transforms back into the wizard and continues to say magic. There are lots of different applications for moving blocks and sensing blocks, and I encourage you to play around with them and see what kind of scripts you can create. Magic. And that concludes part 4 of this Introduction to Scratch 3.0. Next time, we're going to be creating a game using everything that we've learned so far. Thank you for joining me today, and I will see you in part 5.